So good day everyone. Today we are going to learn how to create electrohydraulic projects in our automation studio. So we will use this general sequence and our motion sequence diagram. So we have learned in our past lesson how to create a motion sequence diagram, right? So in our module, I put S0 as the switches, but I put I here because this will be this format will also be used in our PLC programming. So our past examples of circuits is in Euro format. This time we will use US format so that we won't have a hard time adjusting in our transitioning in our PLC programming, since PLC programming uses the US standard. Okay, so here the action that is expected is the cylinder will extend, that's 8 plus, and the cylinder will retract and then reset. So what will happen here is that we are going to use sensors. So our push button here is the I0, and we have sensor I3 and I2. So we will push the button to extend our cylinder. And then once the cylinder is fully extended, it will trigger sensor I3, causing the cylinder to retract automatically. And then when the cylinder is fully retracted, it will then, sensor I2 will be detected, therefore resetting the whole system. Okay, so let's try it in our automation studio. First, we will create our hydraulic setup. So we will go to hydraulic, and then let's get our cylinder here in actuators. We will use a double acting cylinder. Okay, we will set our cylinder, and then we will put sensor. Let's use the proximity sensor. So we will position this here. So this will become I2. And then the other sensor here, position this here so that it will be detected. That will be sensor I3. That's how you put the tag name. Okay. If you forgot to put the tag name, you can just double click that one and you can put the tag name already. Okay, next. I forgot to mention that we are going to use a double solenoid valve. Okay, we have Q2, Q1, and Q2. Let's go back here and let's get our solenoid valve here and directional valve. We are going to use this one because I was used to use this one because this is a solenoid valve, the hydraulic solenoid valve available in our laboratory rooms. Okay, so we are going to use this one. So to put solenoids, we just click the boxes. So in this case, we will use double solenoid valve. So we will put solenoid here and another solenoid here. Okay, so we will call this just that Q0, And the other one will be Q1. Click OK. I'm wrong. Q1 and Q2 pala. We'll double click this to rename that this is Q1. And the other one will be Q2. Sorry about that. You can drag that one to make it closer to its solenoid. Okay, so next we will get our supply with hydraulics and we will find it here, lines. Hydraulic pressure tank. Put it here and return to tank. Return to tank, unlike in pneumatics, in your past subjects, we use here exhaust because air can easily be compressed from the atmosphere. But then hydraulic oils are expensive and we don't want to waste them. So there is return to tank line here so that the oil will just be reused for another activities. Okay. So next we will connect our cylinder to our valve. We will use pressure line. Okay, click the bubble. Make sure it's not red. If it's black, it means that it is connected. Once it is red, it's not connected. Okay, just click that bubble and click this other bubble. Okay, we're done with our hydraulic setup. So we will go to our electrical. Click workshops. And then we will click the electrical control, the US format. Okay, again, we will use US in this one so that we won't be adjusting very hard if we transition to our PLC. Okay, so first we will have our source. We will get 24 volts and the 0 common volts. I'll just drag that. And then since we have this I0, this is our push button. So when we create the electrical circuit, of course we will start with our control circuit, which consists of the inputs. So in our case, we have 3 inputs: the I0, I3, and I2. This one is a push button switch, and these I3 and I2 are your sensors. Okay, so we will position them according to our motion sequence. So we will put I0 first. Let's go to electrical control and then switches. So we will use the push button normally open. There. That would be I0. Okay. So next, since we are familiar with relays, we will use relays so that we can follow our motion sequence. That's one of the specialties of relays. It is used to follow the exact format that we wanted. Okay, so we are just gonna put a contact, normally closed contact here, but we won't be labeling that muna because we will label that later. This is for our reset. Okay, so we will just get back there later. And then, since you already have one input, we will put one relay coil here. You can find it here in out components and coil. Okay. Let's just put that here. That would be M0. It's not 0. M0. It's 0. Okay, just drag that. We will connect all of them later. Okay. And then next, we will put our maintaining contacts, which is the normal to open contact. And we will get that from M0, since it is the first relay that we used here. This will maintain your switch position here. Okay, this will hold your push button in pressed position. Okay. Next, so we're done with our first input. Next input we have I3. So we will put I3. Since that's a sensor, we will use a sensor. So we'll find it here in switches, in proximity switch, normally open. That's right. That would be I3, since we are following our motion sequence. Next, we will put a normally open contact. Let's go to contacts, normally open. Okay, this is what we call the step marker. Okay, we're going to get that at M0. And then we're already now in our coil, so let's get our coil and output components. Let's just connect that here. That would be M1. Okay, let's move this one so that we will not be using a lot of electrical wires later. Okay, so this is the step marker, meaning this M1 won't be energized as long as M0 is not energized. Once this is energized, it's done with its step 1. This is done with step 1. This contact here will close, causing M1 to energize. So you see, step marker is used to follow the sequence we have assigned. So we won't like if M1 is energized but M0 is not energized yet, right? So it should start energizing from 0 and then 1. Okay, I hope you get my point here. So we're done with we will have its latching. Let's get contacts, normally open contact here. So it's maintaining contact, will be maintaining contact or latching is just the same. So we will get it from M1. Okay. Next, we're done with I3. We're down to I2. So actually we can copy things in the Automation Studio. So we will just highlight that since we are creating the same format for I2. Control C, Control V does not it's not allowed here, so we will use this. Copy and paste. Okay. And then we are just going to rename that. That would be I2 This will become M1. To rename, just double click the symbol. This will become M2. And yes, of course, if we're in our last step, you don't have to put anything on top already. Okay, so we are going to connect our control circuit. Let's go to lines and electrical wire. So be careful on this because most students uses pressure line in this area. That becomes their project goal. So electrical uses electrical. Okay, so we're done with our control circuit. Let's go to our power circuit. So this time, power circuits contains our outputs. So our outputs here is the solenoids, Q1 and Q2. So what we are going to do, okay, we're gonna get power sources, still 24 volts and 0 volts. Next, you will get a contact, normally open, one normally open and one normally closed. Normally closed, and then we will get our output component, the solenoid. Okay. We'll drop them so that we won't be using electrical wires anymore. Okay, so my technique in here in our power control is that I always refer to my motion sequence. So, like here, Q1. Q1 will be energized by I0, right? So I will just look at my control circuit. What's the M0 of I0? What's the M of I0? So in this case, the M of I0 is M0. So that's the contact we will put here. So that's M0. And then next, in the close contact, I will just see where does Q1 become minus. So Q1 becomes minus at I3. So I will find I3's M. So I3's M is M1. Okay, so on and so forth. And then this will be our Q1. Okay, we will just copy this line since we are coming with the same line. So this time, this will be Q2. This is a problem with copy. Let's just do this. That will be Q2. So where does Q2 become plus? So it became plus at I3. So what is I3's M? M1. So this will become M1. And where does Q2 became minus? At I2. So what is I2's M? Is M2. So we will put M2 there. Okay, so we will connect them. Let's go to lines, then electrical wire. Before I forgot, I said earlier that we will put the last coil in here in our reset contacts. Our last coil is M2, so we will put M2 here. Okay. So we are ready now. We are ready to run our program. Let's see if we're right. Okay, so to run, click this green button here. So again, the expected output is that when I push this, it will extend, and then it will retract automatically once I3 is detected. Okay, let's do it. Alright, we got it right. So when I pushed it, okay, so let's have a slow-mo. Click this for slow motion. Okay, nag-slow-mo din siya. I released the button, but this MO remain the position. I3 is detected, I3, then this will retract. When I2 is detected, the whole system will reset. Okay? Right. Reset. Okay, that's all for our electrohydraulic project creation. So again, we will save this one. File. Oh, no. I'm sorry, we have to stop it first. I'm sorry. So click File, Save As. So click where you want to save it. In my case, I'm just gonna put it. Where is the stuff? Desktop, EMT40. And click OK and OK, and you're all set. Thank you, everyone.